Hello everyone, how are you all? Very good evening all of you. Although I take little bit more time to join the class, but I can give you guarantee this class will be the best class of algorithm and mind mapping between algorithm, artificial intelligence, compiler, discrete math together. This class will be a best ever class where specially I will focus on all types of algorithm. Yes, I hope I am audible, visible. I hope I am audible, visible. Yes. Audio, video, everything clear? Yes. So this class is going to be the best ever class. I hope so. Because after doing the all analysis of previous year's current trend, I have prepared this class. And this class is here. I have prepared this class where the all complexity analysis, all algorithm analysis and everything we are going to do here. Everything. This will be everything. As I told that, yes, here whatever class we will do, after this class your all confusion and it will be the revision of your understanding algorithm. Okay. And here let's start without wasting time. Let's start. Yes. So first of all, whenever you are starting the algorithm, what is algorithm? Why I am making the connection between all this? Why the connection is there? Although here data structure little bit go down, I am making it little bit correct. So yes. Why I am telling you to make the connection between them? Because if you are thinking the subject differently, if you are thinking that those subjects are all these subjects are different, then it will not work. Is my video stuck? ये video मुझे ना hello okay so here why I am telling you to make the connection between them, because if you are thinking data structure as a different subject, artificial as a different subject, these are not different subject, because all are working ultimately on problem solving. Here these all are ultimately working on problem solving, where you have to solve the problem. To solve the problem, we need some structure that is provided by the data structure. When you want to store the data, you want to work on that data. For that, the data structure is required. And there are different types of data structure, what are array, stack, queue, linked list. There are different types of data structure, right? So many different types of data structure are that. Should I off my video? The video is getting stuck and it will not look good. I'm not able to understand why this video is getting stuck. Okay, no problem. Without video only I will run this. There will be, I think there will be no problem. So here whenever I am trying to solve the problem, then the data structure is required, and in this data structure there is how to store the data. That's why there is array, linked list, stack, queue, hash, all these are there, right? And why the algorithm is required? Algorithm is the step-by-step process how you will solve the problem. And in this algorithm there is the artificial intelligence was also working on the algorithm. Artificial intelligence is also trying to solve the problem. It is also trying to solve the problem. And here is also artificial intelligence is there. Lots of searching algorithms are there, right? Now why I am mixing with compiler? Because ultimately whenever you are writing the program, how the program is execution is going on. When you are writing the program, then how the program will be execute. Program will be executed in compiler only. And there are different phases of compiler through which process the program is going to run. How the computer is working. That is the task of compiler. Now why the discrete math is important? Because discrete math is important to do the knowledge representation, mathematical representation. Whenever you are solving any problem, then the mathematical representation, knowledge representation, for that logical representation, we need that propositional logic, predicate logic. There the propositional logic and predicate logic is here. When you are working with probability, then probability is there. When you are working with the tree, graph, then graph theory is present here. So all the graph related algorithm is actually related with your artificial intelligence, with your data structure, algorithm, everywhere. Whenever you are trying to do the optimization, then optimization problem is coming from the discrete math. So actually these three subjects, if you are taking as a separate way, it's not the separate subject. These all the subjects are together merged. Discrete math, compiler, algorithm, artificial intelligence, data structure, where base is the data structure through which you are going to represent your data. You are going to store the data. And through the algorithm, you are going to solve the problem. For that there are different types of algorithm, where main thing before for your exam, the complexity analysis of different algorithm, very important. All the complexity analysis and how which algorithm is working, that is the most important part and the 100% confirm area. And after doing this class, your all this concept is going to be clear. Okay, so let's start without wasting time. Can you tell me what is the difference between divide and conquer, dynamic program, greedy method, backtracking method? There are different types of method, right? So what are these different types of method? Can you tell me? Can you tell me what are these different types of method? Can you tell me that? Write down in the chat box. Right. So write down in the chat box what are the difference, and let me try as for the last that my video I am able to open or not. If I am able to run the video or not, let me try for the last moment. Please, video should work. Please video device, don't do betray with me today. Please don't do betray with me. Yes, tell me what are the difference? Can you tell me the difference between? Tell me what are the difference between this? I want to know the answer from everyone. Do you know the difference between this? Do you know what are the difference and what are the different types of algorithm? Okay, questions are coming here. Answers are coming here. Yes, these are the different method: greedy, divide and conquer, dynamic approach. So greedy means what? Greedy, divide and conquer, dynamic approach, these are the three different types of algorithm pattern how we are solving, right? So what are the approaches? Greedy approach make the locally optimal choices. Locally optimal choices because it is greedy. Whatever my base solution, I will go for that in each and every step, with the hope that finding the global optimum, that is the main thing, nearby to what is available to me, it is focusing on that. What is available to me, it is focusing on that, and out of that it is going to choose that solution, and it's hope that I will get the global solution. I will get the global solution. Next one is the divide and conquer. Why we are going for divide and conquer? When there is the big problem we are breaking down into sub problem, and after that we are solving the sub problem one by one, and then we are merging it. First divide, then conquer. First divide it, then conquer it. That is called the divide and conquer algorithm. Right, next one is the sub problem to solve the original problem that is going on. Here is the dynamic programming. Why we are working dynamic programming? Dynamic programming is also divided the sub problem, but it is using the recursively and store their solution in, to avoid the repeated calculation. Here it will solve, it will do the sub problem and it will store the result also, and that result you will use in the next step. It is using in the next step. Here no conquer, nothing. Here was it, there is a difference. It is also doing sub problem, it is also doing sub problem, but here after solving you have to conquer the method. Here no need to conquer. You can utilize that, you can utilize it again. That is the utilization possible. Got it? Yes. Yes, clear? Some noise coming. Here after solving you have... What noise coming? What noise coming? I will switch off the video. Let me try with... What noise coming here? Okay, we will run with this only today. Okay, we will run the class like this only today. Now is it okay? Now is it okay? I am switch off the camera, no problem. Hello. I hope now everything is fine. Now everything is fine. Yeah, please don't go for the technical problem, because before exam, now before exam there I cannot go for this technical problem, guys. Please try to adjust. I will provide you the best content. If you are quizzing in the technical issues, if you are thinking about technical issues, then you cannot concentrate on the class. So I will switch off my video. With that switch off video only I will run it. So please concentrate on the content. Okay, I will turn off the video. Okay. So here are the comparison. You can see this comparison we did. So what are the goal here? Greedy algorithm find the best solution among the set of possible solution. Always best solution. Divide and conquer. Solve the problem by dividing into smaller sub problem and solving each sub problem independently. It will divide and it will solve each sub problem independently. Then solution of the sub problem will be the original problem. And dynamic problem, whenever you are coming to dynamic, then solve it breaking into smaller sub problem and solving each sub problem recursively. That is the problem. Okay, these are the problems are clear. So greedy algorithm, order of n log n, order of n depending on problem. Divide and conquer, order of n log n or order of n square. Dynamic problem algorithm is normally happening with order of n square or order of n cube depending on the problem. So with this one you can relate your all the algorithm. Whenever you know okay this is greedy method, then you can assume also that okay my complexity will be between this and this. When you know that it is divide and conquer, then you can do order of log n or n square. When you know this is dynamic, then you can do order of n square or order of n cube. Okay? Yes. So now space complexities. What are the space complexities? In greedy algorithm, space complexity is either order of 1 or order of n. Divide and conquer, order of log n or order of n square. Dynamic, order of n square or order of n cube, because dynamic is always taking more space. Okay. Optimal solution. Greedy method may or may not provide optimal solution. Divide and conquer may or may not provide optimal solution, but dynamic guarantee to provide the optimal solution. Dynamic is always give you guarantee to provide the optimal solution. Okay, ठीक है? Clear? These are very important to remember. What are the greedy method, what are the dynamic method, and what are the other method. Okay. So what to do here? Greedy algorithm, Hoffman coding, Kruskal algorithm, Dijkstra, very popular. Dynamic algorithm, Mart shot, quick shot, binary search. Dynamic programming, Fibonacci series, longest common subsequence, and knapsack problem. These are the all very popular algorithm. You have to remember, must remember that. Is it okay? And now what is backtracking algorithm? What is the meaning of backtracking algorithm? Why we are using backtracking algorithm? The backtracking algorithm technique solving the recursively by trying to build the solution incrementally. One by one it is trying to do the building the solution through the backtracking method. One piece at a time, removing those solution to fail the satisfying the constraint. These are the types of constraint satisfaction problem in AI. Normally so many AI problems are constraint satisfaction problem. And there are different constraint satisfaction problem and backtracking problem. There are three types of backtracking problem: decision problem, optimization problem, and enumeration problem. Okay. So here what are these? These are the standard examples. Sometimes from the examples questions are coming. Write the maze problem, n-queen problem, subset sum problem, map coloring problem, Hamiltonian problem, Sudoku or back Sudoku problem, magnet puzzle problem. These all are the very popular example which is related to AI problems, constraint satisfaction problems. These are the backtracking problem. Okay. Now tell me what will be the answer for this one, and those who are watching, if you can tolerate some issues that you are not able to see me, or sometimes maybe little bit technical issues, if you can tolerate it, whatever knowledge you will gain from this class, I am giving you guarantee that you will get 100% question and your total mind mapping will be done from this class. This type of class I am taking first time. First time I am taking on algorithm this type of class. So please be with me till the last. It will be helpful to you. And tell me what is the answer. And those who are watching, please like, share, subscribe with your friends. And after the exam, definitely I will come to the solution of this problem. And you will not face any other difficulty more. Yes, answers are coming. Option 3 is the correct answer. Very good. You can see this is the question of 15th March 2023. 15th March 2023 question paper. 8 queen problem, closest pair point, string edit problem, knapsack problem. What is this problem? So here 8 queen problem is the backtracking problem. A will be with 4. With that one only you can do the answer. If you know only one, then also you can do other answer. See that. And knapsack problem, actually there are two types of knapsack problem. One is 0-1 knapsack, another is fractional knapsack. Okay, 0-1 knapsack is dynamic approach and fractional knapsack is the greedy approach. There are two types of approach actually. So remember that. This is also important for you. Now tell me, what will be the answer for this one? Now tell me, what will be the answer for this one? This is also the question of UGC NET 2022. UGC NET 2022. What will be the answer for this one? Which of the algorithm approach for using the quick short algorithm? From here always questions are coming. Yes, that is the divide and conquer method. Very good everyone. Now we will do the compare there between the sorting algorithm. There are different types of sorting algorithm, and the sorting algorithm I have divided into two parts. First part of sorting algorithm are that what are using the comparison sort, comparison based sort. Okay, today we are not going to learn all the sorting algorithm separately because all that algorithm already I discussed. Now we are not going for each and every sorting algorithm in detail, each and every algorithm in detail. We will do the mind mapping between them and we will do the comparative analysis, comparative study. Okay. So comparison based algorithm means this type of algorithm are using array and compared with the each other to find the shorter array. Okay. So always it is trying to use the array, and with the array there are some comparison technique going on. So what are those type of algorithm? Bubble sort and insertion sort, selection sort, merge sort, heap sort, quick sort. These all the algorithms are actually your comparison based algorithm. Now what are the complexities? See that bubble sort and insertion sort together you can remember. Here both average and worst case time complexity is n square. Because the mind mapping means separately you cannot remember, rather than that try to make a relation. Bubble sort, insertion sort both are average time complexity order of n square. And base case is n when the array is already sorted. Remember one thing, for the bubble sort, if you are using optimized version, means using the flag, then you can get order of n, otherwise you are not able to get it. But for the best case optimized version, it can be order of n. And for the worst case, when the array is in reverse, then that is the worst case, that is the order of n square only. Okay. Selection sort. Selection sort, best, average, worst, all are order of n square. Best also, worst also, average also, all are n square because there is no chance of improvement. There was two for loop, two inner loop was there, one outer loop, one inner loop was there. That's why there is no chance of improvement. So it is n square itself. Merge sort. Merge sort is using the divide and conquer, where divide is there but the conquer part is not there, right? And the complexity was coming order of n log n. Here how the merge sort algorithm is going on and what is the recurrence relation? Every time Tn equals to 2t n by 2. That was in the merge sort. 2t n by 2 plus to merge it, you are getting the n. In this way the merge sort recurrence relation was there. We are dividing the total array into two parts, then we are solving separately, and after that we will merge them together. That's why your time complexity is order of log n, right? Heap sort. In the heap sort, we are working on heap, and heap I will give you more detail, because heap insertion, heap deletion, all the heap operation questions are coming. But here average case, worst case, best case, all are in log n, because you have to do the heap insertion. How it was working, I will insert one by one, do the heapify operation, and after that make the array. In that way the heap sort was going on. Quick sort, how the quick sort is working? Quick sort is working with the pivot element. We are going to choose the pivot element. All less than element will be in the left hand side, all greater than element will be in the right hand side, and in that way recursively we are calling one by one, and then I am getting the answer in the quick sort. Quick sort is also the divide and conquer. That's why in the quick and quick sort recurrence relation was like this, tk plus n minus k, because where is your pivot element, one side and another side, it will be not always half. In the merge sort it was always half, but here always it will be not half. Sometimes maybe pivot element is here, all the elements in the right hand side. That can be possible, right? That's why worst case is coming like that. One side there is 0 element, another side there are n minus 1 element. That's why here the recurrence relation is coming T0 plus Tn minus 1 Cn. Then your worst case is coming order of n square. Otherwise best case will be when pivot element in the middle, here is half of the array, here is half of the array, then it was recurrence relation 2Tn by 2 plus Cn, just like the merge sort. Then your complexity is order of n log n. Are you able to recall all these algorithm? Why I am just telling you the only concept? Because you have to recall, okay, this was the concept, right? Are you able to recall? Yes or no? Tell me. Yes or no? Are you able to recall all this concept? What was going on in which algorithm? Selection sort, insertion sort, bubble sort, heap sort. How the bubble sort was working? One by one it was going as a bubble. One by one you are comparing the adjacent element. Then again you are comparing the adjacent element. That is the bubble sort, right? Yes. Yes. Good. So here the time complexity. Here is the time complexity. This is very important chart of time complexity. Questions are coming. Questions are coming from here. That is, here you can see the best case, average case, worst case. For the bubble sort, order of n, n square, n square. Space complexity, order of 1. Selection sort, n square, n square, n square. That's why you can remember. That's why I told you that bubble sort and insertion sort same. Same, always remember. Bubble sort and insertion sort same. Right? And selection sort all are n square. Quick sort and merge sort, best case and average case is same. Only difference is worst case is n square for quick sort because of the pivot element. Because of the pivot element. Heap sort all are n log n, n log n, n log n in the heap sort. And complexity here the heap sort is also order of 1 space complexity. But here the space complexity is order of n, quick sort and merge sort. Okay. There are some non-comparison based algorithm. What are the non-comparison based algorithm? Questions are coming from here also, where there are non-comparison based. Non-comparison based algorithm means element of the array not compared to each other to find the sorted array. They are working in different way. And those are the algorithms are radix sort, count sort, bucket sort. Although I did not cover it, but remember the process. Here the best, average, worst case all are nk, where k is the maximum number of digit in the element of array. Counting short is always telling as a best one, because here it is complexity is less. Average case, best case, worst case all are n plus k, where k is the size of the counting array. Okay. Bucket short is best case, average case, time complexity is n plus k, where k is the number of bucket, and worst case is n square. So that's why out of all the sorting algorithm, counting short is always telling as best, because it is giving as a linear time. It is providing as a linear time. So here you can see counting short, each input of the element an integer of a range of 0 to k. This question came previous years also. Within 0 to k, what will be the complexity? Complexity is actually we can write n plus k. Asymptotically we can write as order of n. From here question came, and it is also can be your question key which algorithm it is. That is actually counting short. Remember that. In this range, whenever you are doing and your complexity is coming like this, that is your counting short. Radix short, the number of digit and the bucket, that is nk. Bucket short also n plus k. Radix is nk and bucket short is n plus k. But the worst case also here n plus k. Here the worst case is n square. That's why you can go for counting short in the worst case also. It will be in the your linear time. Okay? Clear? So here is your all complexity: bubble short, selection short, insertion short, counting short, radix short, march short, heap short, shell short. Another algorithm is there, shell short, where the complexity is also n log n, but worst case is n square, average case is n log n. So here march short, quick short, heap short, all are n log n. You can see these all are actually n log n. Okay. Only for the quick short and the shell short, the worst case is n square. Like that way you can remember. You have to do the mind mapping. Separately you cannot remember. Remember it like a mind mapping, so that it will be easy for you. And bubble short and insertion short are like same. Selection short is all n square. Is that clear? 100% sure you are getting question from here. Always questions are coming from here. That is 100% sure area. Clear to everyone? Yes. Is that clear? Chalo, now tell me what will be the answer for this. If it is clear, then tell me what will be the answer for this. And after doing the answer, you have to tell me the complexities also. Do the answer. What will be the answer? Tell me. Rajkumar, memorizing options are not good. Memorizing options are not good. Just now I explained. Still you are memorizing option and now you are telling the answer. What will be the answer? Tell me everyone. Two, three, four. Yes. Here in the original official one, here was a mistake. They did not provide the original answer key, original correct answer, because here mart sort, bubble sort, linear search, binary search. Binary search time complexity is what? Binary search, how it is working? That is an array, and for binary search it should be in ascending order. Array should be in ascending order, right? After that you are trying to find out the mid element, and then you are working either in one part or another part. So there are two parts we are dividing, but working on one part only. We are working on one part only. So that's why, what was the recurrence relation of binary search? What was the recurrence relation of the binary search? How to do the recurrence relation? It was AT n by b plus fn. So A is the number of sub problem. How many sub problem was there, and what is the size of sub problem? Number of sub problem was 1, and size of the sub problem was t n by 2, right? That's why it was coming log n. It is not n log n, it is log n. So binary search is coming log n. Linear search is n, right? And bubble sort is n square, and mart sort is n log n. So which one is less? Less is log n. So that's why D will be the less. Then after that n, then after that n log n, then finally bubble sort, because it is asking you as per the worst case. As per the worst case. So in the worst case I can do the answer. This is my answer, right? Yes. So here your answer will be this one. All the recurrence relation and the complexity both are important. You have to remember recurrence relation. You have to remember the how the algorithm was working, and you have to remember the complexities also. Let me close the window. So many shouting is coming. Is this clear to everyone? Yes. Okay. Now from here also questions are coming. What is the, which one is in place algorithm, which one is stable algorithm, which one is online offline technique? From here also very popular questions are coming. So in place and out place, what is the meaning? Sometimes it is called out place, sometimes it is called not in place. Sometimes it is called not in place also. In place means you are taking the array, and whatever comparison, whatever work you are doing on that array itself. You are not taking any separate array for doing the work, for solving the problem, right? That is called in place. But whenever you are taking something extra space, extra array, then that is called not in place algorithm or out place algorithm. Okay, extra memory we are adding. So that's why remember that only the mart sort algorithm is the out place technique, because mart sort is taking extra array. In the mart sort always we are dividing the array into two parts, and this two part is an extra array. That extra array is required. That's why mart sort is not a in place algorithm, it is a out place algorithm, right? Other than that, all other sorting algorithm is actually in place. Okay, among the non comparison based algorithm, this is under comparison based algorithm. Among non comparison based algorithm, all are actually out place technique. That is the counting sort, bucket sort, and all these algorithms are actually out place. Okay, remember that also. all non-comparison based, because they are not using array. In that array they are extra technique it is using. So it use the hash table for the sorting array. It is not using extra array but using the hash table for sorting the array, and that's why these all are the counting sort and bucket sort. They are the outplace algorithm and they are not comparison based. This is also remember because statement type question can come कि non-comparison based algorithm are not in place algorithm. Assertion reason can also come. Reason they are using hash table. So is it assertion reason correct or not? This type of question can also come. Remember that. Okay. Clear? Comparison based, non-comparison based, in place, out place. Next one is the online or offline technique. Online technique or offline technique. A sorting technique is considered as online if it can accept new data while procedure is ongoing. Okay. So complete data is not required to start the sorting operation here. That is the online. It is called the online technique. Online if it accepts the new data while proceeding the ongoing process, mean process is going on. Now you are adding some new data. It is allowing it. That is means online. Means I am online. So now you will ask me question. I will answer. But those who will watch the recording, maybe they will comment but maybe they will not get reply because I will be not at that time online. That's why maybe I will be not take your doubts. Right? To clear your doubts always you have to be online. That is the online method. So only insertion sort qualified this because underlying algorithm. It uses the process of array, not just the element. It is not using the element, it is using the process of array from left to right. If new elements are added in the right, it will not impact in the ongoing operation. Here this is very important. Question can come from here. Which one is the online approach and why insertion sort is the online approach? Because insertion sort is going from left to right one by one. If you are adding one element in the right hand side, then it will not impact your process. That's why it is called the online approach. Is that clear? Yes? Is that clear? Clear? Remember that and note it down. Question can come from here according to the current pattern only. I am telling you these are very important. Okay. Next one is the stable and unstable technique. Which one is stable? Which one is unstable? A sorting technique is stable if it does not change the order of the element. If it is not changing the order of the element with the same value, it is not changing the order of the element, then that is called stable. Okay. Out of comparison based technique, bubble sort, insertion sort, merge sort, they are the stable algorithm. Selection sort is unstable because it may change the order of the element with same value. It can change the place of the same value. That's why selection sort is the unstable algorithm. Other than that, these all are stable algorithm. What is the example? You can see this example 4 and 4. These are the same values, right? You can consider that. Here this is an array 4, 4, 1, 3. This is an array. Out of that, in the first iteration, the element 1 is swapped with 4 and the second iteration 0th position it is again swapped. If this swapping is going on between this order means actually they are not stable because they are doing swapping with the same value. They are doing swapping with the same value means they are not stable. That's why selection sort is not a stable algorithm. Clear? Remember and note it down. These are very very important points for your exam. Okay. So here you can see the comparative analysis, that in place algorithm. In place algorithm, these are the in place algorithm, that is bubble sort, selection sort, all these. Only mark sort is not a in place algorithm. Stable, if you are coming to the stable, then bubble sort is stable, insertion sort is stable, and mark sort is also stable. But selection sort, quick sort and heap sort is also not the stable. So these three algorithms are not stable. Yes, heap sort is also unstable. So that is I provide here. So remember this chart, which one is in place, which one is stable. And from here also high chance you can get the question. High chance is there. Clear? Are you taking notes? Or after class again you will shout, ma'am, PDF. Are you taking notes or not? Please write down this table at least, or you can take it. That write down this table in your notebook. If you are writing, then it will be for lifetime in your notebook. If you are not writing, then it is gone. Okay. Yes. So time and space complexity for the heap data structure. This is also very very important. Repeated questions are coming on here. This is repeated question. Repeated questions are coming from here, that list of operations. So here what are the operation in heap? Insertion operation, deletion operation, searching operation, getting max and mean values. These are the different operation going on in a heap. Right, in that way the heap sort is going on. Whenever you are working with heap, then you have to, at the time of insertion, what was going on, I am inserting in the last and I am doing swapping, then doing heapify. So insertion operation in the heap, best case is order of 1, worst case is order of log n, average case is order of log n. Deletion of the best case is order of 1, worst case order of log n, average case order of log n. Okay. Searching, best case order of 1, worst case order of n, and average case also order of n. For searching max or mean, getting mean or max, sorting, here the order of n log n, creating heap order of n log n, heapify, that is order of n. Very very important. 2 to 3 times they ask question from this area, different way, and remember that. Is that clear? Do this question. Question is in front of you. Do it. Tell me what will be the answer for this one. Yes, answers are coming here. So here what will be the answer? Just now I told that build max heap, that is order of n. Right? Heapify is order of n. Building the heap, that will be order of n. But it is given order of log n. That's why option B is wrong. You can eliminate option B and you can get the answer. A and C is the correct answer. This is correct, this is correct. So answer will be this one. Why guys you are doing mistake? Just now I discussed with you that heapify, building heap, Building heap means EP5 operation, that is order of n, and it is given that order of log n. That is wrong. Why you are doing option 1? I am showing, after that I am asking you, then why you are doing wrong? First of all I am discussing, then I am asking, then why you are doing wrong? It is not good. Okay, now this is the next important part. Next important part is that the comparison between the red black tree and AVL tree. I will cover the concept and I will ask you the related sum question. All the question I am not going, because if I am focusing on question, then your revision will be not done. So I will do the concept and I will come to the question. Okay. So it is also very important. Questions are coming from here because these are the balance tree. What are these? They are working on the balancing, right? These are balance tree. What is the meaning of balance tree? Balance tree meaning is right hand side and the left hand side of the tree. Difference between the right hand side and the left hand side, the difference will be not more than 1, mod 1. It cannot be more than 1. Sometimes we are writing -1, 0 or +1. That is the +1. That will be the difference between them. Height of those tree will be not more than that. So here are two methods. First method is definitely AVL is important. Definitely AVL is important. Already we did the question also in AVL. Today I am not going on those questions. This is the mind mapping class, means our concept and what is important, that is required, and related some question. So this was the main thing of the balancing factor. Balancing, first of all we are checking the balancing factor. The difference between the height, we are checking the height of the right subtree and left subtree, and difference between right subtree left subtree height will be either -1 or 0 or +1. Otherwise we have to do the balance. Now in the red black tree, how the balancing is going on? This is the self balancing provided by the painting each node with the two color, that is the red and black color. So when tree is modified, the new tree is subsequently arranged and repainted. Means the painting is going on here. So it's required 1 bit for color information. That is an extra information required for 1 bit in each node. So time complexity is order of log n. So how it is working? Root will be always black. The root will be always black. See that all the roots are actually black. All null leaves are black and both children are red and red node are black. All the children of the red node will be black here. Okay, and same number of black. Every simple path will be there in the descending leaf. Same black will be there, and path from the root node will be this. So it is also order of log n. Here whenever you are coming to the AVL, then AVL is also checking the height difference. It is the height balancing. Root always black. So the height difference will be there. Height difference we are taking with right and left, and it will be always less than 2, and we have to do the rebalancing between the height, and faster retrieval strictly balanced. So here you can see the comparative analysis between them. Comparative analysis is lookup. How the lookup is going on? Red black tree has fewer lookup because not strictly balanced. AVL tree is faster lookup than red black because it is strictly balanced here. Okay. See, just remember the difference. If you remember the difference, that will be enough. I am not going for any algorithm detail. Just go for the difference. Comparative study is important here. As per the paper analysis I am telling you. And before exam, if I am going for all algorithm, then so again it will take 1 or 2 weeks. Okay, so here the color of the node either red or black. Main concept is that here no color. How insertion and removal is going on? Here the insertion and removal is going on that key tree provides the faster insertion and removal than the AVL. Because tree is fewer rotation. Here no that much rotation is not there. Lookup means searching. Lookup means searching. Rotation that much is not there, but here rotation, too much rotation, because it is strict balancing. That's why here insertion and removal will be little bit slower. Okay. Storage, red black tree, extra 1 bit is required for the color. These are definitely you can understand. Extra red or blue black color we need the extra bit. But AVL tree no extra bit is required. Store the balancing factor or the height of the each node as an integer. For that it is required, but extra 1 bit is not there. Okay. Next one is the searching. Searching not provided efficient searching. It's provided efficient searching here. Use, where we are using red black tree most uses for the language libraries like map, multi-map, multi-set. These are the library operations. Where AVLT we are using in database where faster retrieval are required. The use are very important. Remember that. Here it does not give any balancing factor, but it will have the balancing factor. Take less process for the balancing, more process for the balancing. Here these are the main difference on comparison between red black and AVL. Must remember, and I hope you can understand actual points. Those are the actual points. It is strictly balanced AVL. Red black is not that much strictly balanced. Color is a factor, that's why extra bit is required. Here not required. Clear? Difference is clear? Why I am telling? Because here is the question. Because here is the question. Here is a question. Yes, here what will be the answer? Here your answer will be this one is true, that AVL tree for more balance compared to the red black tree, but cause rotation. That is correct, just now I told. Here this one is wrong, because why? Why? Because here it is given that the red black tree end node has height is greater than this one. It is not true. It cannot be more than, it's never more than 2 log n plus 1. In red black tree, height cannot be, the height never more than 2 log n plus 1. Where n is the total number of internal node, because height will be always order of log n. Actually the height will be always order of log n, and it cannot be more than log n plus 1. It is given that greater than n plus 1, log n plus 1, that is wrong. And AVL tree end node height less than this, that is also wrong. So that's why your answer will be this one is false, but this one is true. Okay, ठीक है. And what will be the AVL tree height? What will be the AVL tree height? That is also you can write down. AVL tree height is always order of log n. For this one also, for your blade black tree also, for AVL tree also, height will be order of log n. AVL tree shorting will be order of log n, and minimal number of AVL tree is n greater than 2. So the subtree can be n minus 1 other than height is n minus 2. Either n minus 1 or n minus 2 means difference between them will be always 1 or 2. So that is the height. Height will be this one. Okay. Now log 2. The minimum height I am writing here. The minimum height of AVL tree will be floor log base to n, and maximum it can't exist, it can't exceed it can't exceed 1.44 multiply into log 2 base 1. It can't exceed this. Okay, if the AVL tree height is 8, then the number of node will be, if the AVL tree height is 8, that is given to you, then the number of node will be 2 to the power h plus 1 minus 1. That is also you can write down. So minimum height will be log n, maximum height will be this one, but here it is given ki root 5n plus 2, that is wrong. So that's why this will be wrong. Now we will do the comparison between Dijkstra, Floyd-Warshall, Bellman-Ford. These are the path algorithm. These are the shortest path algorithm. Okay, these are the shortest path algorithm. ठीक है? Okay, no problem. So now you can see what are the main difference. Bellman-Ford and Dijkstra both are single source shortest path. First of all, this one Bellman-Ford, Dijkstra both are single source shortest path. ठीक है? Yes. अच्छा, let me try once. I am also feeling bad. At least here is some bit rate issue. Just for the bit rate issue only the problem is there. I hope now it will work. It is more than 2000 kbps and my bit rate is also set 2000 kbps. So I hope so now it will work. Let's see. If it is getting stuck again, then I will again switch off it. Okay, if it is getting stuck again, then I will again switch off this. Chalo. So here both are single source shortest path algorithm, and the both determine the shortest distance of each rate of the single source vertex. Now we follow the dynamic approach for the Bellman-Ford. Here for the Bellman-Ford we are using dynamic approach, and greedy approach for the Dijkstra. Dijkstra is the greedy approach. Okay. So Dijkstra algorithm, how it is working? Dijkstra algorithm is very similar to Prim's and Kruskal. Do you learn, right? Ki Prim's, it is very similar to Prim's. Like Prim's MST, we generate here the shortest path also. Bellman-Ford, how it is working? It is just a dynamic algorithm, and here it is calculate the shortest path using the bottom up manner, and it first calculate the shortest distance of or at most one edge of the path, then calculate the shortest path of at most two edge, and so on. One by one, it is dynamic approach. For one edge, then two edge, then three edge, we are using the matrix, right? This is the first matrix. When I am taking one edge through 1, then after that we are going through 1 and 2, then through 1, 2, 3, like that way it was working. So that is bend and short fold. And Floyd-Warshall is like that, it is an example of all pair shortest path, where we are calculating the path between everyone, between all the pair it will be going on. That's why it is called the all pair shortest path algorithm. So difference between Bellman-Ford and Dijkstra. What is the difference? Bellman-Ford work when negative edge, that is a problem. This is the problem of the Dijkstra. Dijkstra cannot work in the negative edge. Dijkstra may not work, but Bellman-Ford can work, and it can detect the negative edge cycle also. That is the advantage of Bellman-Ford, but it is a disadvantage of the Dijkstra. Result contain the vertices which contain information about each other, vertices to be connected, and the result contain the vertices containing whole information. Here this Dijkstra and Bellman-Ford is related to your routing algorithm also in networking. Distance vector routing, link state routing, those routing algorithm are depending on these algorithm actually. That is also a mind mapping required whenever you are learning routing algorithm, that is exactly depending on these algorithm. Okay. So which is taking care of all the information. So here it can only implement distributed way, and here it can implement easily in distributed way. The Dijkstra algorithm time complexity is order of VE, and here it is order of E log V. Dynamic approach taken here and greedy approach taken here. This is the difference between Dijkstra and Bellman-Ford. Okay. Yes. Next one is that here you can see how the Floyd-Warshall is working. So what is the difference between Dijkstra and Floyd-Warshall? So Dijkstra is a single source first of all, and it is the all pair shortest path. That is the first difference. So for all pair you have to do, here you are doing Dijkstra using E log V. Here it is order of V cube, and Dijkstra does not work for negative edge. Floyd-Warshall work for negative edge but not in negative edge cycle. This is the comparison between Dijkstra and Floyd-Warshall. Very important difference. Repeated questions are coming. I am showing you the question just now. So Dijkstra is the shortest path algorithm for finding all pair, but time complexity if I am using Dijkstra. Sometime question are coming like that. For all pair shortest path, if you are using Dijkstra, then what will be the complexity? Then your complexity will be like VE log V, means it will be V cube log V. That is using Dijkstra. But the advantage is that if I am using the Floyd-Warshall, then it is coming to V cube. That is the that is actually your advantage. Sometimes questions are coming from here. You are using Dijkstra, then what will be the complexity? Okay. This one, Rukaiya, this one. Paid learner, I will upload the PDF, don't worry. Rukaiya, I think you are paid learner, right? I will upload this PDF. After the class only, I separately prepared this PDF today. So I will upload this. After the class only, I will upload. So here. Next one, unlike the Dijkstra algorithm, Floyd-Warshall can implement into the distributed way. So Dijkstra algorithm may fail to output the correct answer on the graph of negative edge. That is the main problem. Here now tell me what will be the answer for this one, and I will do the analysis between prims and Kruskal's also. E log V when we are using VE both, right? Because here I am using V. Why that? See that E log V normal Dijkstra, but all pair, for that I have to multiply V, right? It is the for single source E log V, but when I am taking all, then I have to multiply V. Is it or not? Normal Dijkstra E log V, but all pair whenever I am doing, then V I have to multiply. That's why V multiply VE log V, and VE log V, E equals to V minus 1. So in the place of E I can put V into V minus 1 log V, right? V into V minus 1 log V, that is I can put. So it will become now V square. So actually it will be V naught, it will be V square, because it is the matrix, for the matrix, right? Clear? Yes. Now tell me what will be the answer. What will be the answer for this one? Do this one. I am coming, taking my water. I am coming. Okay, answers are coming. Here answer will be 2. Some students are writing 2, some students are writing 4. But your answer is 2 here, not 4. Answer will be 2, not 4. Why you are doing 4? Here you are doing mistake. With the prims and cruscals you are doing mistake. No. With the Warshall also you are doing mistake. So Dijkstra algorithm, what is going on? That is store the total cost from the source node to the current node. B, Prim's algorithm, what it is doing? That is store the minimum cost. Warshall, what it is doing? Calculate the path matrix, because all pair, right? And finally the Kruskal, finding the minimum spanning tree. Okay, if you are using here, so here you have to focus on this one, that is if you are focusing Prims and Kruskal, then you will be doing mistake, because Prims is also the minimum spanning tree and Kruskal is also minimum spanning tree, and that's why you are doing mistake. Keep Prims you are marking with 4, and that's why mistake is coming, right? Yes, I know that you are doing mistake here. So what you have to do when this type of confusion are there, then don't confuse with the Prims and Kruskal. Try to focus on Warshall and Dijkstra. Definitely Dijkstra will be A with 3, that is sure. And Warshall, try to see that Warshall, C is here 1 and C is here 2. As a C is 2, is it minimum cost edge? Warshall is not working with minimum cost edge. Warshall is working with path matrix. So that should be your identifier of the answer. Whenever there is the confusion, then come out from the confusion from other option. You have to change your focus. Okay, A and C, you have to focus on that. Don't focus on B and D, then you will create the confusion here. Okay. So now tell me, what is the main difference between Prim's and Kruskal? That is also little bit revision is required. Wait. What is the difference between Prim's and Kruskal, and how the Prim's and Kruskal is working, right? What is the difference? So if you are taking an graph like this, maybe this is a simple graph I am taking. Okay, so A, B, C, D, and this is 2, this is 5, this is 1, this is 3, and this is maybe 4, and here this one is 4 and this one is maybe 6. So this is the graph. Now in this graph, what are the difference between Prim's and Kruskal? How Prim's will work and how Kruskal will work? This is very important algorithm, Prim's and Kruskal. That is related to your graph theory also and in your data structure algorithm also. Both are required. So Prim's can start with any point. Prim's can start with any point. So if I am starting with A, if my starting point is A, then Prim's will add those edges only which is connected with me, like that AB is connected with this, that is 2, AC is connected with that, that is 6, and AD is also connected with that, that is 1. Now out of them it will take which one is minimum, that is 1. So out of that it will draw the graph here, that is A to D. A to D it will take, that is 1. If I am thinking about Kruskal, Kruskal will make the list of all available one in a ascending order, like this way, ki AD that is 1, then after that AB that is 2, then after that CD that is capital small, all are mixed together, sorry, and that is 3, then BD that is 4, then BC that is 5, then finally AC that is 6. That is the first main difference. Kruskal is making all the list of the edges what is available in the graph. All the edges it will make the list, right? Yes. Again my video stuck. All the edges it will make the list, and then it will start with the first one, right? Then it will start the first one. That is when it will start with the AD. Here also it will take A, then D, A, then D. Then after that, which one it will take? From here now D came. Whenever now D came, now it will add the connection. So it is connected with DC, that is 3. It is connected with DB, that is 4. This connection is done. So is there any other connection? No. So now out of these all, which one is minimum, that it will take. That is the AB. So minimum is AB. So it will take the AB. So here also it will take this minimum, that is AB. So it is AB, that is 2, this is 1. Now after that, what is going on? Whenever it's visit the B, whenever B is visited, then it can take the connection, that is now it is connected with BC. Now it can take the BC here, and it is the main difference, right? I am not going in detail more, just the difference is clear. I am not going in detail more. I will not go in detail. Just the difference between the Prim's and Kruskal, how it is working, that was important. So I hope it is clear. Yes, And what are the complexity? What are the complexity? Complexity of Prim's algorithm is order of v square, and Kruskal's algorithm is order of e log v. That is the time complexity, right? Prim's and Kruskal, this is the difference, and the time complexity, order of v square, and another one is order of e log v. Yes, right? So then do this question. Do this question. Tell me what will be the answer. Don't memorize the answer. Tell me what is the correct answer. I am zooming it. Solve it, then answer. I am zooming it. First check it. Image, I am zooming it. Draw the image in your notebook. Then I will zoom out. Draw the image in your notebook. Then I will zoom out. Draw the image, please. I am not showing option. Before that only answers are coming, because you are recalling the answer. Draw the image. Done. Now answer. Now tell me the answer. Yes, options I am showing. Now tell me the answer. Answer everyone. What will be the correct answer? I can see more than 90 learners are here, but answers are not coming from everyone. Don't be the only listener. Try to be the active learners. Try to participate. Try to answer so that your learning will be complete with me. How to do it? See that here it is asking you about the minimum spanning tree algorithm. Using minimum spanning tree algorithm, you are starting with A, that is AB. You can see all are starting, and it is actually how it can work. See that minimum age, it is working with minimum age, means I can go for Kruskal, right? Definitely I can go for Kruskal. So minimum age I will go. So this is 1, this is 1. So either I can start with AB or I can start with DF. If I am starting with AB, then DF is the next one. If I am starting with DF, then AB is the next one. So what is my order? Either AB or BA. So all are correct. AB, BA, that is okay. Now after AB, BA, what is the next one? Next one is the 2. This is 2, this is 2. So 2 means which one? There are 2 possibilities. Here also 2 possibilities. What are the possibilities? If I am taking in DF, that is possible that here I can take BF or I can take DCD. Right? Here also I can take BF or CD. So where is BF? Here is BF, here is CD. So after AB, I have to take CD, means any order it can be BA, CD or anything. So here is CD, here is CD, here is CD. But here after C, E is taken. After C anyhow E cannot come. Because order will be like that. First I have to check that 1, then 2, then 3 as per the weight. So here E, whenever you are coming to E, that is DE. DE is weight 3. Before completing 2, how you can take 3? That is not possible. Right? Question was asking which one cannot be the added in the order. Which one is not the correct order. So definitely this is not my correct order. So option 3 will be your answer. That option 3 is not my correct order. Is that clear? Using Kruskal's. Using Kruskal, how to do? Is it clear? Yes. Clear to everyone? I am coming. I am coming. So here I am going to the spanning tree. This is the some important concept about spanning tree. These concepts are required. It is the spanning tree, and here in the spanning tree, when n, it has n minus 1 edges and n number of nodes. Okay, when n number of nodes, then n minus 1 edges will be there. Removing E minus n plus edges, it will make the spanning tree. Okay, and maximum n to the power n minus 2 spanning tree is possible for a complete graph. For a complete graph, n to the power n minus 2 spanning tree is possible here, right? And here always it is called that removing one edge from the spanning tree will make the graph minimally connected. That's why it is called minimally connected, maximally acyclic. Very, very important statement type, assertion, reason type question can come from here. Adding one edge to the minimum spinning tree will create the circuit loop. That's why it is called maximally acyclic. Okay, these are the your civil network where we are using. Here Prim's and Kruskal, this is the difference between Prim's and Kruskal. I will ask you one question on Prim's. Tell me what will be the answer for this. You have to do in Prim's. Using Prim's algorithm you have to do it. I am zooming it. First do it, then I will show you the options. Draw the graph. Using Prim's algorithm, solve it. Then I will show you the answer. Learn networking from the video. Learn networking from the video also. My video is getting stuck, but my audio is coming clear. But actual thing is that whatever device I am using for video and audio, that is same. Same camera is for video also, and in that same camera audio is also there. But my video getting stuck, audio coming clear because of network. Network I am using high bandwidth, but what is the expectation of this OBS Studio? It is not fulfilling the expectation of bitrate, and that's why my video is getting stuck. So I have to manage this one, which bitrate I should fix, so that in the video there will be no problem. This is the complete understanding of your networking. Audio is not taking that much bandwidth rather than video. Video is taking bandwidth, and that's why my video is getting stuck. Okay, so tell me what will be the answer now. Tell me the answer. Options it is. Here is the options. Tell me the answer. These are the options. I am zooming the option part. Here are the option. Here are the option. Okay, all are coming, all are giving answer. So here your answer will be both. Those who are telling only one, I will say you are wrong, because 1 and 3 both are correct. 1 is also correct, 3 is also correct. Not only 1. 1, 3 both are correct. 1 is also correct, 3 is also correct. Yes. So why it is? Because it is prims. Whenever you are starting with A, then A will go to B, because this is 4. That is okay. So A will go to B with 4. But after that, here this is also 8, this is also 8. So after B, I can take C, AB. After that, I can take BC also, or AB. After that, I can take AH also, because this is also 8, this is also 8. Right? Yes. So that's why AB after that AH, that is also possible. AB after that BC, that is also possible. This is not my answer, this is not my answer. Both are will be possible. So your answer will be this one. This is the way you have to do prims. Okay, these are the questions we did. Someone was asking about Digestra. How the Digestra is working? Digestra is working like that. I think Ankit was asking, right? Ankit. So select the source from the given. It is set the distance between the 0, the starting distance will be 0, and all other will be infinite. And main concept is here, that is if du plus wuv less than dv, then it will be du plus wuv. That is the main concept of Digestra. So how it will work? Here you can see this is a graph. In this graph, if I am starting with this one, that is 0. Now at the starting I will take this one is 0, then all other are infinite. I will start with 0 initially, then all other is infinite. Okay. After that I will check that AB 0 plus 10, that is 10. AC 0 plus 5, that is 5. So in the next row I can update 10 and 5. Other than that, any one of them is not reachable from me. That's why I cannot update. Out of them, which one is minimum? 5 is the minimum. So I will take the 5 and I can go to AC. That is this one. Then after that, can I take a mouse pointer? Yes, I think so. But mouse pointer is not working. Okay, so here after that what will be? Now I have selected C. Now you are in C. From the C now you can reach to D also. Now you can reach to E also. Now you can reach to B also. So via C now you can calculate again. So actually via C to E, if you are calculating, then you can see C to B. C to B, that is 5 plus 3 is 8. Previously it was 10. So now you can take the 8. And then C to E. C to E if you are doing, then you are getting 5 plus 2 7. And A to C to D, that is 14. 5 plus 9 is 14. So you are getting 14 here. So now you are selecting 7 here. So as you are selecting 7, A, C, E now. So now after E, now you have to check through the E, B. You can see through the E, B, there is no way. So that is 8 only. But through the E, you can reach to D. That is 5 plus 2, 7. 7 plus 6, that is 13. Now you are updating this 13. But out of 13 and 8, which one is minimum? 8 is minimum. But the 8 came actually from here. Actually 8 came from here. That is ACB 8. And finally you are selecting this one, that is ACD. So all shortest path you can see: A to C 5, A to E 7, A to B 8, A to D 9. This is the way the Dijkstra is working. As you request and you are regular learners, so that's why I explain here. I hope it is clear to you. Yes, who was asking? Ankit, are you there? Who was asking? Dijkstra. Aruna was asking. Aruna, are you there? Clear? Okay. So now we will go for next thing is, so this is done, Dijkstra and Kruskal. So here tell me what will be the answer for this one. What will be the answer for this one? Tell me. Today we will end all the algorithm, everything. If you are with me, I will complete everything today. Full screen not no means. Yes, so answers are coming. Option 3 will be the correct answer. Bell-Manford is order of n multiply m. Kruskal algorithm order of m log n. That is E log v, same thing. E log v, m log n, same thing. Okay. Floyd-Warshall, that is order of n cube. And last one is the topological sort, that is n plus m. How the topological sort is going on? Topological sort is going on like this way. We are utilizing topological sort like this way. Okay, maybe I am drawing a graph like this. This is a graph, okay? A, B, C, D. So how the topological sort will work? Topological sort is checking the in degree. What is the in degree? Here the in degree is 0, here in degree is 1, here in degree is 2, here in degree is 2. So I will start from the where in degree is 0. I will start from there. So I can see A is my in degree 0. When I am taking A, then after that I will remove the connection with A. after removing the connection with A, now this will be now 0, this is now 1, and that is 2 only. So now I can take B, because now B is 0. After taking 0 B, I can remove this one and I can remove this one. These are now removed. Now after that again update the value. So here now in degree is 1 and here now in degree is 0. So now that's why I can start with C now. So when I am starting with C, then now I can remove this one finally. Finally this is removed, means this is now 0. Now this is D. This is called the topological sort. And the application of topological sort is in the serializability. When they are asking about the serial sequence, after doing the graph, we are drawing the precedence graph. In this way only we are drawing the precedence graph in the DBMS, transaction concurrency. In transaction concurrency, whenever you are drawing the DBMS precedence graph, then they are asking which one is the serial order. So using topological sort, you have to do the serial order. Okay, and it is the mind mapping with DBMS. All subjects are related. All, each and every subject are related, and there is the relation. Serializability, whenever you are doing conflict serializability, then you have to do precedence graph, and after that if there is no cycle, then what will be the correct sequence. From here also 10 marks question can come. Using the topological sort you have to solve it, and that is the application of topological sort. Remember that. Okay, clear? Chalo, there are some more algorithm. Do the question directly, and through the question only you can write down the algorithm complexity. You can write down this, and after that I am coming to more. These are some extra algorithm. Here you can do it, and after that you can write it. Do this one. What will be the answer? Answer. I am waiting for your answer, everyone. Okay, answers are coming. Option 2 is the correct answer. So here it is the different approach of Fibonacci series. How you can do the Fibonacci series, different approach. So when you are using the recursive method, this is the complexity. When you are using memorization method, for memorization method, this is the complexity. Whenever you are using the addition and multiplication method, then this is the complexity. And when you are determining by Bitonic tour, then the complexity is this one. Remember it, write down it. All everything algorithm definitely we cannot go in detail, and you can remember, because complexity list will help you. Here another one you can see, the matrix multiplication. If we use the divide and conquer algorithm, then what is the complexity and recurrence relation? Complexity and recurrence relation. Yes, here your answer will be this one, because the running time will be order of n to the power cube, and recurrence relation whenever it is the divide and conquer. And with the n cube, definitely you can understand ki recurrence relation will be this one by using the master theorem ATN by B plus Fn, right? By using that, definitely it will be this one. So this is your recurrence relation, and the master theorem is the one of the application of this. That is also correct. So that's why A, C will be the correct answer for this one. Okay, now here do this one. Breadth first, Robin curve, depth first, hip shot, quick shot. Breadth first, depth first, I am coming in detail with the AI. Now we will move to AI search algorithm. Most important, all the algorithms are done here. Now we will move to AI algorithms. All are ready? All are ready. AI algorithm. No, before that the NP complete, NP hard and FFT topic is there. That we will cover. Then we will move to AI. And all the paid learner, can you please compromise today's class? If you can compromise, then all this will be done. If you can compromise, then everything I can cover here, and I hope it will be helpful for you also. Today's evening class, if you are compromising, then I can continue little bit more. Yes, answer will be option 3 definitely. Using the hip shot and quick shot, you can do that, right? So here you can see the quick shot. Here it is the worst case. You can do with the worst case, because D hip shot is always with this one, that is order of n log n, and quick shot is order of n square. So I can do this. So it is the answer here. This is not the answer. 4 5 here, also 4 5 here, also 4 5. So with this one only I can do the answer. Other than that, breadth first search and depth first search, both are there. So here breadth first search is order of V plus E. Depth first search is also order of V plus E. Robin curve algorithm is actually this one, that is theta of n minus m a minus l. Okay, that is here. Okay, okay. Yes. Now here P problem, NP problem, NP hard problem. I am trying to do one by one issue, like a one by one I am moving. Let's see. So here this is very popular topic. Every time they are asking question from here. P problem, NP hard problem. One by one we are moving. So here, what is the difference between P problem and NP problem? Today Rohit was asking that, right? What is the difference between P and NP? P problem are the set of problem which can be solved in polynomial time by deterministic algorithm. By deterministic algorithm you can solve it in polynomial time. That is the P problem. It is related to your TOC and compiler, right? All are related. Why I told? This is related to your TOC and compiler. When you are coming to NP problem can be the problem where it is solved by non-deterministic in a non-deterministic polynomial time. You learn NPDA, DPDA. So whenever you are solving the problem, NPDA, DPDA, Turing machine, everything is there, right? So these all are related here. You can see. So P problem solved verified in the polynomial time. NP problem cannot be obtained in polynomial time, but solution is given. It can be verified in polynomial time. It can be verified. So P problem is the subset of NP problem, and NP problem are the superset of P problem. Actually, NP problem are the superset of the P problem. All P problem are deterministic in nature. all NP problem are non-deterministic in nature. Okay. So what are the P problem? That is selection sort, linear search. These are in polynomial type. NP problem, traveling salesman problem, knapsack problem. Traveling salesman problem and knapsack problem are the NP problem. Very very important. I am asking you question. You can see how many question was there from this topic. Now come to the NP hard and NP complete. Now what is the difference between NP hard and NP complete? NP hard problem can be solved if and only if there is NP complete problem. Say that Y means some problem is there, that is X, that is a NP hard problem, and with that related another problem is there, that is Y, that is reducible to X in polynomial. So ultimately there are different algorithms. One is not in polynomial time solvable, another is you can solve, you can reduce it to polynomial. That's why it is called the NP hard. NP complete problem can be solved by non-deterministic algorithm or the Turing machine in polynomial time. Okay. So to solve the problem, it do not have to be NP. And to solve the problem, it must be both NP and NP hard problem. To solve it, it have to be NP and NP hard. Time is unknown in NP hard. Time is fixed in NP hard. NP hard is not a decision problem. NP complete is executable decision problem. NP hard and NP or not all NP hard problem are NP complete, but all NP complete problem are ultimately NP hard. Do not have the decision problem here. It is exclusively decision problem. It is the optimized problem. Here the decision problem we are using. What are the example? I am going little bit so that you can see that example. These examples are important for you. Hamiltonian problem, vertex problem are the NP hard problem, and NP complete problem. Determine the graph is Hamiltonian cycle. Hamiltonian cycle, that is the NP complete. Determine whether Boolean formula is satisfiable or not, and circuit satisfiability problem. These all are the NP complete problem. Okay. Clear? Is that clear? Can I ask you question? Do the question. Do the question. Tell me what will be the answer. Quickly do it. Quickly do the answer. Yes, answer will be 1. If the NP complete problem is P, then P equals to NP. That is correct. TSP, traveling salesman problem, that is NP. SAT, satisfiability problem, that is Boolean satisfiability problem, that is also NP. Hamiltonian circuit problem is not NP complete, that is wrong. It is NP complete. So that's why your answer will be A, B and C. Now tell me what will be the answer for this one. What will be the answer for this one? Yes, answers are coming here. Yes. So here it is asking about the Boolean combinational circuit composed with a and or not. So satisfiable means it is the Boolean satisfiability problem. So the circuit satisfiability problem in the class of NP. Yes, Boolean satisfiability problem in the class of NP. The circuit satisfiability problem at least hard in any language of NP, that is also correct. The circuit satisfiability problem is the NP complete problem. This is also correct. So all are correct. You are getting here ABC. So definitely ABC will be correct. No need to think about this one. Okay. Now tell me what will be the answer for this one. Okay, now today NPP clear. Achha, very good. Very good. If it is clear to you, it is my pleasure. Do this. I hope today so many things will be clear, and from today's class, after exam, please come back to these classes, these mind mapping classes. Come back to the mind mapping classes and comment it ki how many question you got. Okay, comment that how many question you got after the class, after the exam. Minesh, don't focus on all the option. Don't focus on all the option. Try to find out which you know and try to find out the correct answer. That is the good. Yes. So here answer will be ACE. Hamiltonian problem is the NP complete problem. Yes. Here if a bipartite graph odd number of vertices, it is wrong, because whenever bipartite graph odd number of vertices, cycle will be not there. And if the cycle is not there, then you cannot create a cycle of Hamiltonian. So it will be not possible. So option B is not possible. Eliminate the option B. Now out of that ADE, here is ACE. So A and E and A and E here. So only C and D. Which one is correct? So C is Hamiltonian path problem can be solved in the polynomial time on acyclic graph. Cannot be solved. That is correct, because that's why it was that is correct only because that's why it is the coming here. So that's why your answer will be ACE. Right? AC and E is the correct answer. That is NP complete problem in polynomial time solvable. That is P equals to NP. See that same statement they are copying. If you are remember this statement, same statement they will copy. And by copying the statement, you can remember it and you can do the answer. Right? You can remember and you can answer. NP hard, NP complete. How to remember? You are practicing so many questions I am explaining. After that also you are not able to remember. Practice it. So here next important topic is FFT. So many times they are asking question on FFT. Very important algorithm. My concept is important. Okay. So what is FFT? So I copy it from an article directly. So here it is allow us to multiply the two polynomial. You saw that polynomial multiplication. Length n in order of n log n time, which is better for the trivial multiplication what is taking order of n square time. That is the main focus of fast Fourier transformation. Another name is FFT. Normally if you are doing multiplication, previously also you saw a question on multiplication of two polynomial. It will take order of n square time. But you can reduce it to order of n log n time using this FFT algorithm. How it is can be done? Obviously also two long number can be reduced to multiply to the polynomial. Two long number can be multiplied also in order of n log n time. Okay. So it is discovery on that time where it is given. So but actually this is, so FFT algorithm present here to n log n here, so but does not work in the multiply of arbitrary big polynomial with the arbitrary large coefficient, or multiplying arbitrary bigger number. Like this it cannot handle. Okay, so the handle the polynomial size 10 to the power 5 with the smallest coefficient, or multiplying the two number with size of 10 to the power 6, but some point of range, because it have also the capacity. Beyond capacity it cannot go. It have a limited capacity. Beyond capacity this algorithm cannot go. This is the main concept of FFT. The fast Fourier algorithm computes the discrete Fourier transformation, that is DFT, of sequence, and its inverse, that is IDFT. Fast Fourier analysis convert a signal from the original domain, often in the time or space, and represent its frequency domain, and vice versa. That is also a work of use of FFT. Here FFT algorithm computes here DFT using the order of n log n time, multiplies and addend. There are many variant of FFT algorithm normally. So this is the main concept of FFT. I am asking you some question. With the question you can make a notes on FFT. So tell me what will be the answer. Just now I told you, you can do the answer, and with the answer you can do the mind mapping on FFT. Tell me what will be the answer for this one. Yes, so FFT are compression technique. Here the compression technique use the encoded digital video and audio information to help and analyze the signal in frequency domain. Just now I discuss here the FFT, how it is going on. It is doing the discrete Fourier transformation DFT sequence and inverse IDFT, like that. Yes, yes. Okay, whatever you are able to remember, try to remember that much. Now you can see these are the different FFT: parallel FFT, iterative FFT, and it is evaluation of polynomial using Horner method, and here it is the two polynomial represented in the point of value. Means ultimately all are working in polynomial. Then what are the complexities? All polynomial multiplication, polynomial work. Then what are the complexities? You can do the mind mapping between all the approaches of polynomial. All the approaches of polynomial. See that those who did in morning class, now you are able to recall. That is the advantage. In morning class one time I ask, after that again we are discussing, and again I am asking. By doing two times, ultimately you are able to recall the answer, right? Morning you are not able to do, but now you are able to do. That is a good sign. That is a good sign. Yes. So yes, now you are able to do it, because parallel FFT, that is order of a log n. Iterative FFT, that is order of n log n. Iterative. Evaluation of polynomial in Horner method, whenever we are doing, that is theta n square, because it is taking more time. And here two polynomial that represent in point value form. Point value form when it is given, then we can solve it in order of n time. That is actually the linear time. So which one is better? Definitely this is the better. First better one, this one, that is the n log n. That is the iterative one. First one is log n, this is better. Then after that n, then after that n log n, then after that n square. In that way you can remember, right? Yes, in that way you can remember which one is more better. This is the sequence. One by one you can sequence this order of n. This one is then first of all order of log n. This is order of log n, then order of n, then order of n log n, then order of n square. So which one was order of log n? Order of log n was your parallel FFT. Parallel FFT is order of log n. Then order of n. Order of n is what? That is polynomial representing point value. Point value, that is order of n. N log n is what? N log n is iterative FFT. Iterative FFT, that is n log n. N square is which one? N square is the Horner method. These are all working on polynomial. Okay. Okay. One day memory, then gone means you have to revise more. If you are revising more, then it will not go. Try to revise it more. Now tell me. That's why I am giving you question in a same area, same type of question, trying to give to your mind mapping. So you have to little bit work on that. You can remember. If you are working a little bit on this, you can remember. Tell me, what will be the answer for this one? It's already 2 hours class over. Given FFT, we can have dash time procedure multiplying polynomial this degree, input output representation coefficient n log n. Yes, just now we did. With n log n time you can solve that FFT problem. So now you can remember that yes, FFT problem can be solved in n log n time. Right? Clear? So this is the end of normal algorithm. Now we are going to start the AI related all the searching algorithm. Now we will do AI related all the searching algorithm mind mapping. Take a 1 minute break. Take a 1 minute break. A little bit 1 minute break, take it, and meet you after the break. Okay, so that okay, 1 minute or 2 minute break. That's a 2 minute break. Take 2 minute break, then I am coming back. Meet you after the break. Okay, okay, coming in 2 minutes. Come back everyone. Come back everyone. Come back, come back, come back everyone. Come back, come back, come back. All of you please come back. Yes, so here everyone, all of you come back. Bacha party, come back, come back. We are going to start AI. Come back. Are you present? Attendance please. Satya, Jaspreet, Deepa, Lopa, Lakshmi Rana. Lakshmi Rana, then Lekka. Hello, hello. Come back everyone. King Gaming. Lakshmikant, Jaspreet, Akhila, Monica, Chandrika, Lopa, Tamil, Nishu, Kirtana, CRD Sit, Mukesh, Muktesh, Kishori, Saranya, Abarna, Sharma, Deepa, Rajkumar, all are present. Chalo, let's start. So now the thing is that in AI searching, AI is all working in the searching algorithm. There are different searching algorithm. Most important searching algorithm here are there. This is called divided into two parts. That is uninformed search and informed search. So uninformed search is the depth first search and breadth first search and uniform cost search. Informed search is greedy search, A-star algorithm, graph based search algorithm. These all are the coming under informed. So what is the difference between uninformed and informed? What is not information? No information is there, that is uninformed. Uninformed means no information about the path, cost from the current state to the goal state. You are here, you don't know that where is your destination, what is the total distance, what will be the cost, that is not given to you. Don't know any domain specific information. Informed search means what? The path. General paper 1 is going on in this channel only. Priyobroto Ghosh. Tulasi ma'am is taking the class, follow that classes. 11:15 she is taking class, 11:15, 11:30. So the path cost, current state or goal state is the calculated and select the minimum path cost for the next. Here the path cost is known, the information is there to me, and with that information I can calculate and I can select the next path. Okay, yes. So it does not use the knowledge of searching process. It finds the solution slow as compared to informed search. It is used the knowledge of searching process to find the solution more quickly because we have information, and here we are using the heuristic method. That is the very important method here, new introduced, that is the heuristic method. Here we are using that heuristic method. It is less effective and cost is high. It is more effective, cost is low. Here problem solve in given information. Here additional info or assumption. Heuristic means the assumption, guessing is going on here. No suggestion given the solution. Here provided the direction regarding the solution. You can go to this way so that you can get the solution. So here are the uninformed search, breadth first search, depth first search, depth limited search, iterative depending search, bidirectional search. Here graph based search, greedy search, A star, hill climbing, these all are coming under informed search. Okay. So let's start with breadth first search, BFS, because all the AI algorithm is ultimately depending on BFS and DFS. Upcoming all the algorithm main base is BFS and DFS. So what are the main difference between BFS and DFS? BFS is using queue. BFL will work with queue. That is last in first out order. DFS is using stack. It is using stack, and that is it last in first out? It is first in first out, and this is last in first out. Okay, so it is using the stack. So BFS is the label order traversal. Label order means this is your tree. In the tree, one by one, first label I will cover, then second label I will cover, then third label I will cover. This is the simple thing of BFS, right? DFS is using like that. First I will start from here, then what is connected I will go here, then I cannot move here. After that I am going here, I cannot move here, then I can go here. That is going from depth to depth. Where the connection is there, it can move to that only. Okay, all the connected one. Whenever you move to the next node, you cannot go back to the previous one. You cannot go back here. That is a problem. So here this is the difference between BFS and DFS, main difference. I will come to the example directly, and through the example it will be more clear. So it is the example you can see of the BFS. When I am starting with 1, this is my first starting. We are creating the open list and close list. So 1, after that 2, 3, 4, then 6, 5, 7, then 8, 9, and I am reaching to the goal node. This is the way it is working normally. Okay, so open and close list I am taking one by one, it is going on. See that 1, then 2, 3, 4, then after that it is coming here. But how this is working? Why this is coming? You will say that ma'am, this is so normal, but it is not coming like that. It is not coming like that because whenever you are doing BFS, then you have to maintain like this way. Here if you are taking the queue, always remember, I will start from 1. So whenever I am sending 1 to the close list, I have to insert the connected one, that is what are connected with me. 1, 2, 3 is connected with me. So that's why 2, 3, 4 I will send here, right? Then after that, whenever 1 is out, then I am taking 2 into the close node. Whenever I am taking 2 into the close node, I have to insert which one is connected with 2, that is 3 and 6. So now 6 will be inserted here. So whenever 6 is inserted where, whenever I am taking out 3, then with the 3 what are connected, that is 5 is connected. Now I can insert the 5. This is the way BFS is going on. Whenever you are taking out, then you have to insert the node which is connected with me. If it is normal tree, one connection is there, then so directly I can do. But here are multiple connection, and that is the problem. When there are multiple connection, how I can handle? This is the way we are handling, that is called the BFS, right? I am not going in detail, just you can recall the concept. So here is the application of breadth first search, that is you have discovered the solution in least curve, fewest solution. These are the application, that is shared network, social network, global and all, bipartite or not. This is a very important testing that the graph is bipartite or not. This is the application of BFS. Now whenever you are coming to DFS, DFS is depth first search. As I told, I will start from 1 and and now I can move to any one of them. Either I can move to 2, or I can move to 3, or I can move to 4. Out of them, whenever I choose the 2, then this one are discarded, then I cannot go ahead more. Then I have to connect with that which is connected with 2. So 3 is connected with 2, so that till now the option is there, I can go to 3, but anyhow I cannot go for 4. Okay, so that's why now here are the option 3 and 4. So then I am visiting 1, then 2. After 2 I am going to 6. Now I am here, that's why I am going to 6. From the 6, which one is connected to me, I can go here. See that here 6 is not connected with anyone. Should I stop here? No, because in the stack till now 4 and 3 is there. Now from 3 I can do again. That is the difference. That from 6 to I cannot move, because all are now incoming arrow, any one is not the outgoing arrow. So should I stop? No, I don't stop, because here in the stack 4 and 3 was available. Top of the element was 3, so I can pop 3 and I can visit again. With the 3, now 5 is connected. Now I can insert 5 and then I can take the 5 here. Then I am visiting 5. From the 5 now, where I can go to 7. So now I can visit 7. This is the way depth first search is working. It is a very important here what to do. Concept is here what to do. Okay, so here it is the depth first search. So when you are coming to depth first search, you can see there are some application, right? There are some problem. So that's why we are coming to best first search, which is the combination of the breadth first and depth first. The good thing of DFS and BFS combiningly making the best first. That here DFS and BFS together is making the best first algorithm. Only difference is that here we are using the priority queue. Here we are using the priority queue. That is the main difference. So whenever you are using the priority queue, how it will handle? It is handling like that. I am going to directly example. Just let me open the, first of all I will ask you a question on DFS, BFS. Then I will ask you best first search, so that all concept will be clear. So here was the difference between BFS and DFS. This is best first search. It is using FIFO, LIFO, and it is suitable for searching. This is the decision making tree for the puzzle. Here is the complexity order of B plus E, and adjacency. This is coming whenever you are using the adjacency list, then order of B plus E. Whenever you are using adjacency matrix, then this is order of B square. Same thing for DFS also. Here siblings are visited before the children. Here children are visited before sibling. Very very important point for DFS and BFS. Need the traversal time are deleted from the queue. Visited node are added to the stack and removed when they are not needed. Okay. BFS no concept of backtracking, but in DFS backtracking is there. Just now we did backtracking. When I was stuck, then I did backtracking to the previous one. That is a very important part. BFS use various applications such as bipartite graph, shortest path. DFS is using such as acyclic graph and topological shortening. BFS required memory element, DFS required less memory. BFS optimal finding shortest path, DFS not optimal to finding the shortest path. These are the very important difference between BFS and DFS, and very very important algorithm. Very 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 important algorithm. So BFS is slow compared to DFS. DFS is fast. BFS space complexity is more critical compared to time complexity. Here it is less. BFS no problem trapping into the finite loop. But DFS can trap in infinite loop. It is a problem of DFS. It can trap into infinite loop. When the target is closed for the source, the BFS perform better. When the target is far from the source, then DFS is preferable. These are the area, means when I can use which algorithm, what are the problem. These are most important and must note it down. Is that clear? Then tell me what will be the answer for this one. Be active, guys. If you are not active, then I cannot understand you are there or not. Try to be little bit active. Tell me what will be the answer. I message to the paid learners so that the class is cancelled and we will continue this class. If you all are active here, then definitely I can get also little bit energy. Try to be active more. Yes, answers are coming. Answers are coming. Option 3 is the correct answer. C for Chennai. Yes, try to be. So here what will be the correct answer? It is breadth first search, BFS. As I am starting with M. When I am starting with M, so M I will take, right? Whenever M is coming out here, then I can insert N, Q, R. So but here it is N, O, P. Anyhow O cannot come, P cannot come, because they are not connected with M. So that is not possible. Now next one. Whenever you are coming to the next one, I am inserting N here. N here. So whenever I am inserting N, what is possible here? Here what is possible? At that time, the possible is that I am inserting N, then what are the M, O and M, Q, O. So Q, M, how P is possible? Not possible, right? But here last one also, here this is the possible, that is Q, M, N. So that's why it is the answer. Yes, right. Now tell me what will be the answer for this one. Now tell me what will be the answer for this one. Consider the following graph and do the DFS. Do the answer. No question number. Give me the answer, I can understand. No question number. Give me the answer, I can understand. Yes, answer will be D. Because just check it, A to B, then B to E, then E to G, then G to H, H to F. No problem. But here the second one, whenever you are coming to that, then is it okay? I am coming to A to B, then B to F, then F to E. F and E, there is no connection between F, E. So that's why 2 is not possible. 2 is eliminated. And after that 1 and 4. Here also 1 and 4. 3 is correct or not? A, B, F. A, B, F. Then H. Then G. Then E. Yes, this is correct. So that's why here I can do the answer 1, 3, 4. 4 is correct. So that will be the answer. Yes. Now tell me, it is so I already did. This is we already did. So now I will ask. Now we will go for the best first search. What was going on here? What was going on here? That is the depth first search, and after that we came to best first search. What I told? Only the difference in best first search is that how you are doing the BFS, same way you will do here. But at the time of insertion into the queue, you have to check the weight. According to weight, you have to make it in ascending order. If it is old data is already given, again with the old data and new data, check it which one is correct order, make the order and again do the searching. That is only the difference in best first search. Priority, that is the difference. We are using the priority queue here, right? Yes. So I am going to the example directly. So here open queue, how it is working, and now here it is the special cases. What are the special cases? That is greedy best first search algorithm and the A star algorithm. Okay. So what is the analysis? The worst case complexity of the best first search is order of n log n, where n is the number of node, and in worst case it will all the node you have to visit. So come to the example, do this question and tell me what will be the answer using best first search. Using best first search, what will be the answer? I am zooming it, do it, then you can answer. Do it, then I will show you the option. Do it, do it, do it. Without doing, don't answer. Do it. Do it, then answer. Practicing is good. Options. Yes, these are the options. Okay, answers are coming. So what will be the correct answer? Correct answer is option 1. Those who are telling option D, they are wrong. So how to do it? What I told you, have to maintain the priority queue here. You are starting with A. So I am starting with A. When A is coming out, Then which one I can insert? I can insert C and I can insert F. C weight is 2 and F weight is 7. So C is 2 here, F is 7 here. That is inserted. Now which one I should visit? C. So A, after that C. Whenever I am visiting C, which one is connected with me? F is connected with me and B is connected with me. So F to already here. Now I can do that. Here you can see C to F and F C to B. This is there, right? So now you can see C to B, that is now 10. C to B, this is now 10, right? Now I am visiting which one? I am visiting definitely F. This is the F. So I am visiting F. When I am visiting F, which one now I can visit? I can visit D. Now D is 1 here. It is 1. So here the Q you have to adjust now. Now you have to adjust it because the less one is the less, right? Should I visit B or I should visit D? So I have to insert. Whenever I am inserting, then I have to shuffle the Q. That is, B will go here and D will come here because it is 1 and B is 10. That is, the shuffling is required because I have to maintain the priority queue. So after that now D will come. That's why A, C, F, D. You are doing A, C, D, F. That is your wrong. It will be A, C, F, D because it is maintaining priority queue. It is not the normal BFS. So after that last one is E. So with the D here it is whenever you are visiting D, then E. So here now you can visit E because B will be again shuffled. Again B will be shuffled because B will be now again go and again now you can come to E. E will be 2 and B will be 10. Now E I can visit. And after that whenever you are coming to E, now it is not required anything. So it is the correct order. This is the correct order. Okay, clear? Why this is? What is best for search? Don't do mistake. Now there are the application of best first search. What I told, that is greedy best first search and A star algorithm. These are application of best first search, special classes. So greedy means you are applying here the greedy method only. So greedy best first search AI is finding the most promising path from the given starting point and prioritizing the path for the most promising one and go ahead. That is the just greedy algorithm applying here. Okay, greedy best first search evaluating the cost of each possible path, then expanding the path which one is lowest. That is the more approach it is writing. And this algorithm use the heuristic function to determine which path is most promising. Here the heuristic value is added. Normal best first search heuristic value was not there, but in greedy best first search we use the heuristic function. That is the extra addition. So here you can see the advantages. This is simple and implemented, fast, efficient, low memory, flexible, and efficiency is more. Disadvantage, it can provide it inaccurate result because of heuristic value. Greedy best first search not always guarantee for the optimal solution. Okay, but it is finding the most promising one. Local optima problem is there. Locally you can be trapped. That is the local optima problem. Heuristic function is a big problem here because your heuristic value is depending on the algorithm is correct or not. Okay, okay. No, whenever you are able to reach to goal node, then you can stop. You reach to goal node means you able to stop. No need to go. The start and goal. I am able to reach to goal means I can stop. Here lack of completeness. This problem is also there. It will be not complete. Best first search is not a complete algorithm. Okay. So here if you are coming to the comparison, this is the comparison. That comparison will help you in the complexity. I am zooming little bit so that it will be good. BFS, DFS, UCS means uniform cost search, and A star BFS greedy version. Complexity order of B to the power D, BFS also order of B to the power M. Uniform cost search is order of B to the power C by epsilon. This is little bit different. A star order of BD, BFS is also order of BD. Okay, BFS normal breadth first search, yes, and best first search, that is different. Here it is space complexity order of B to the power D. Optimality, from here actually questions is coming in optimality and completeness. Very very important question are coming from here. For BFS it is optimal, it is complete, but DFS is not optimal, not complete. Uniform cost search optimal and complete. A star also optimal, complete. BFS, that is the best first search, not optimal but complete. It is not optimal but complete. Very very important, and complexities are also very very important. Repeated questions are coming from here. Okay, ठीक है, must note it down. Here uniform cost search, did I missed? Best first search, depth first search, uniform cost search. Did I missed anything? Achha, I took the comparison only. Then yes, breadth first, depth first. Here is your conclusion. Yes, this is the uniform cost search. You can come to the uniform cost search. Here uniform cost search is working in the lowest cost path. Expand the lowest cost path and implement using the priority queue. It is also priority queue ultimately. Here how it is working, you can see. Always it will go the open list and close list, and some heuristic values are added. You can see some heuristic value here. So I will start with this. I will put it into the closed. Now these are my connection 2 and 5. So with 2 and 5. Cost is here. I took the 0. So 0 plus 2 is 2. 0 plus here it is 1. 0 plus 1 means 1. Out of them which one is less? 1 is the less. So I will take this one. Then whenever I am visiting this one, then after that already 2 was present, and from here I can visit the 9. That's why I am adding this. Out of that, which and when there is same value, because both are 2, which one is old one, that is only we are going to take. This is the way how uniform cost search is working. When 9 is there already, I am visiting 2. When I have visiting 2, then I can visit 6 also. I can visit 3 also. Same way I will put into the queue 6 and 3. Now I will put the cost also. After putting the cost, what is the minimum cost? I will take the minimum cost. This is the way how uniform cost search is working. Depth limited search means it is the version of DFS search only, where we are setting the limit to which depth I will go. If you are getting solution in that depth, it is okay. If you are not getting, then you are stopped. Why we are doing it? Because the problem was there in the DFS to go for a infinite loop. That was a problem. We can overcome this problem by setting the depth. That is the depth limited search. Nothing else. Same concept. Only the depth you will set. If there is at least one goal state in a at depth 1, then algorithm guarantee to find out the goal, but not guarantee to find out the optimal path. So here it is order of BL and it is order of B to the power L. Now iterative, depth, limit, depth first, iterative depending search. What it is? So see that from previously there was DFS. Then after that you come to depth limited. You set a depth. Now it is iterative depth. Means what is going on? One by one I will increase the depth. First I will go for depth 1. Then I will go for depth 2. Then I will go for depth 3. Like that way we will increase. If I am getting answer in depth 1, I will stop. If I am not getting answer, then I will go for depth 2. If I am not getting answer, then I will go for depth 3. In that way the depth is increasing here. That is only the addition. One by one we are adding some extra thing. That is called the depth limited search. Is it okay? Clear? Yes. So just do the mind mapping. What is going on one by one. Next one is bidirectional search. Bidirectional is more interesting. You are searching from both direction. You will start from starting also, end also. And in middle, whenever you are getting answer, then you will stop. It will do the, from initially it will do the forward, and from this one it will do the backward. From initially it will do forward, and from end it will do the backward. The idea behind bidirectional search, simultaneously both forward from the initial and backward from the goal. And whenever in middle I am getting the answer, I will stop. That is the bidirectional search. Here the mind mapping is very important. Questions are coming from here. Okay, that's why the advantage is that previously your complexity was B to the power D, and here complexity is B to the power D by 2. Because both side I am doing, in middle I can get the answer. That is the advantage, and that's why it is called the bidirectional start. Okay, not always going to be possible, likely feasible, but we can reversible. The algorithm is complete and optimal, both. Okay. So here these are the repeated state, how they are repeating state. You can see the comparison between these are all uninformed search. Previously I show you the informed search, and these are all uninformed search. BFS, DFS, DLS, DIFL, IDS and BDS. DLS means depth limited search. DFID means depth first iterative search. BDS means bidirectional search. Here you can see this is complete. Yes. DFS no. DLS it is complete if I greater than D. This one is also yes, this one is also yes. Optimal, only this one is optimal. DFS no, DLS no, but iterative one is optimal, and BDS, that is bidirectional, that is also optimal. Time complexity, order of D, order of N, order of B to the power L, order of B to the power D, order of D by 2, that is bidirectional. Space complexity also B to the power D, BM, BL, BD, B to the power B by 2. This is very important, this chart, and previously whatever I provide you this chart. These are the two charts here. This one. These both are very important. And now I will go for the question. You can see why I am telling you important. The questions are there. Maybe you are thinking that why ma'am is giving, but I am showing you. Acha, A star algorithm, little bit do the revision of A star, although you know, but A star is a very important algorithm. So A star, why it is working? It is the search method and best popular technique. It is working on the base first search. It is also one version of base first search only, right? Here main thing is G, H and F. Three part is there. When you are starting your current node, your goal node. From here to here, here to here. Already you reach here. So that's why you are doing Fn equals to Gn plus Hn. Gn is this value what is known to you. Hn is your heuristic value. You will take the heuristic value and then you will go ahead. That is the A-star algorithm. So here you can see the example of A-star algorithm. Same way it is working. Source node, add the open list, explore the node adjacent to this, same concept. Calculate the cost for all node discover in the step. Open list increasing based on the cost. Move current working node in the open list. First node will be that, then go ahead. Why this is the difference? Where is the difference? That is the heuristic value. We are setting the heuristic values here. That is the extra difference. In best first search the heuristic value was not there. But here you will set the heuristic value. When you are taking this, the heuristic value is 12. You are sending this into the closed list. Now you are coming to 10 and 5. So 10 plus 2 will be 12. And here it is 1 plus 12, that is 13. Out of them this is minimum, that's why it will be sent to closed list. So now I am visiting this one. Now I can visit this one and this one. Same way I will do Gn plus Hn. That's why it will be added here 12, 13 and 13. Out of that which one is minimum, I am going to choose this one. That is the extra addition. Concept is same. Always it is working like same. Only difference will be that I will take it Fn value with Gn plus Hn. That is the extra addition. You are able to relate with the example. All these algorithm, how one by one is moving. You are able to relate it, reply, and then you are able to reach to the goal node. This is the way how it is working. Yes. So now you can tell me the answer. Do this answer. Do the answer. What will be the answer? Just now I explained. Now tell me. Greedy best first search, recursive best first search, A star, SMA star. Yes, so here your answer will be this one. Greedy best first search is related with incomplete even if the search space is finite. I told you, right? It is the incomplete one. Yes. Now A star algorithm. How the A star algorithm is working? Here, let me do a little bit correction. So now I think it is visible to you. Yes. So here, that's why the greedy best first search is this one, that is incomplete even if search space is finite. A star algorithm computation and space complexity is too high because Gn equals Fn equals to Gn plus Hn. Recursive best first search, whenever you are coming to recursive version, then the space complexity is order of D, and depth, that is the deepest optimal solution. In depth you are going, that's why recursive version. Last one is the SMA search. SMA search is the optimal if optimal solution is reachable, otherwise the best reachable optimal solution. Now tell me what will be the answer for this one. Greedy best first search, A star, recursive best first, and iterative depending A star. What will be the answer? Yes, here answer will be 4, because while greedy base first search, select the node to expand if optimal path that node has been found. This is the greedy approach. A star means time complexity depends on quality of heuristic totally, that is A star algorithm. Recursive best first search, whenever you are working with recursive best first search, that is recursive suffer from excessive node generation. Iterative depending A star algorithm, iterative depending means avoid iteration is going on, avoid the substantial overhead associated, keeping with the short in queue of the node. So answer will be this one. Now see this. Here it is branch and bound, steepest ascent, constraint satisfaction, mean end analysis. Join it. Yes, here your answer will be, see that hill climbing, steepest ascent, constraint satisfaction, mean end. What are that? Steepest ascent, there are 3 types of hill climbing algorithm, right? What are the 3 types of hill climbing algorithm? And what are the constraint satisfaction problem? There are 3 types of hill climbing algorithm. What are those? Tell me, what are those algorithms? 3 types of hill climbing algorithms. What are those algorithms? Here was the hill climbing algorithm. When you are coming to hill climbing algorithm, then these are the things of hill climbing algorithm. Simple hill climbing algorithm which is not evaluating the neighbor node, state at a time and select the first one and optimize this. That is the simple hill climbing algorithm. And next one is the steepest ascent hill climbing algorithm that examines the neighbor node of the current state and select all the neighbor node to the closest goal node. That is the steepest ascent. And last one was the stochastic. Stochastic is it does not examine all the neighbor and before decision node the select. That is the stochastic. Stochastic means another name of stochastic is random. It is related to genetic algorithm also. And what was the mean end analysis? Mean end analysis is like that. If this is my starting one, if like this is my starting one, and if this is my ending one, then I have to think what is the difference between the start node and the goal node. This is the start node and this is the goal node. What are the difference between start and goal, and after that it will take the decision. So the difference between start and goal, it can see that this circle go out and this circle is expand. So you will come by step. Okay, this is the one circle is going out. Then what is going on? Circle is getting larger and the diamond is getting smaller. So these are the difference. So this is called the mean end analysis. And constraint satisfaction problem, so I told already what are the constraint satisfaction problem. There are so many constraints will be given. You have to satisfy the constraint and you have to go ahead. Map coloring problem, water jug problem, game. These all are the constraint satisfaction problem. So that's why your answer is this one. That is the answer. Here you are able to get the answer, that is this one. Now tell me what will be the answer for this one. Greedy best first search, lowest cost first, and A star algorithm. What will be the answer for this? All the algorithm is done. Today all types of algorithm I tried to cover, so that there will be no problem, I hope so. Answer. Yes, here the answer will be 4. Greedy base first search, A star algorithm, that is working on heuristic. This one will be heuristic, that is, see that here you will be confused. Here this one is C with 1, definitely C with 1. So here this is not my answer, this is not my answer, either this or this. Then the greedy base first search, lowest cost. So heuristic, which one is working with heuristic? The greedy one is working with heuristic. Minimal cost, normal cost, it is working. So that's why this is the answer. Yes, right, 4 is the answer, definitely. Now finally all these algorithms are done. Last mind mapping, as I told, that is with the compiler. That is the last mind mapping is required with the compiler. Why ma'am, why with the compiler any mind mapping is required? Because here whatever till now you did, whatever you did, that is in problem solving. So whenever you are solving the problem, you are writing the algorithm. The algorithm is written in program. The program should be execute. So whenever you are executing the program, then what are the phases? You have to go through some phases, right? As previously also you see that all the problems are NP hard, NP complete, that is related, right? So how this is related with the compiler? Because compiler is helping you to solve the problem. So whenever I am running a program, then how this is running, how compiler is working, that is the thing. And here also I am giving you some 100% confirm question from where questions are coming. So that is just now we will do, then we will go ahead. So here the cross compiler, first question, already question came from here. Cross compiler means that run on machine A and produce the code of another machine B. In 2023 only from here question came. That is called the cross compiler. You are running and you are working. Another one is source to source compiler. That is this compiler that translates the source code written into one program language, and this will go for the another program language. Okay, yes. Now you will go for this one. Say that before 7:30 I will end you, don't worry. So here it is lexical analyzer, syntax analyzer, semantic analyzer. Those who are the paid learner, if you want to take rest, you can go. You can go because just yesterday you did it. Little bit revision we will do here and I will also end. If you want to go, you can. Lexical, syntax, semantic, intermediate, code generation, machine independent, generate code generator, then machine dependent. These are the very important phases whenever you are running the program, whenever you are executing the program. So first of all we are writing into high level language, that is C, C++, Java, anything. Then it will come to the preprocessor. In the preprocessor it will remove the hash include, hash define this file. Then it will create the assembly language program. Assembly language is not the binary language and it is not the high level language also. It is in between, like the 8085 language we saw, that is the assembly language. It is not binary, not high level, in between something. That is the assembly language. So it is the combination of machine instruction and some other data that will be converted. Then it is coming to assembler. Assembler will be hardware plus operating system, and have any assembler they are using for assembling the assembly language to the machine code. Assembly language will be converted to now machine code. And then the interpreter, what interpreter is doing? Interpreter is converting the high level language to the low level machine. High level to the low level machine, just like a compiler. That is the task of the interpreter. Last one is the relocatable machine code, means what you can relocate from one machine to another machine. That is totally independent. Linker and loader, what the linker and loader is doing? It's convert the relocatable code into absolute code and tries to run the program resulting into the running. So here absolute code, because the linking some library file, the linker loads the variety of object file into the single file and it is loading to the loader. That is the task of the linker and loader. Very important task. So here are the phases of the compiler: lexical, syntax, semantic, intermediate. Very important. In the synthesis phase, these are the code optimizer and code generator. So just directly I am going for the question. What is going on in the lexical phase? Lexical phase is going on, I am telling you, that is the token. It is working with token. Syntax working with the grammar, parse tree. Semantic working with the meaning of the data or language. Intermediate code generator to will generate it. That is going on here. So token, syntax analyzer recognizing the sentence, program syntax language, semantic analyzer check the semantic, that is meaning, and intermediate code generator generate the abstract code. That is going on here in the different phases. So quickly I will ask you some question and after that we will end the class. Tell me what will be the answer. quickly do it. Those who are watching till now, I hope you get the benefit from today's class, and 100% sure question you will get. 100% sure you will get the question. Tell me what will be the answer quickly. Yes. So compiler keywords and the language recognized during the lexical analysis. Keywords, that is the, here it is lexical. Then the next one. Do the next one. This is a very much related area where every program will execute. How the program is executing, that is the most important. Till now we solve problem, algorithm, but how they are executing, why the time is required, order of n, order of log n, why, this is the requirement, right? Yes, here lexical analysis is working with the regular expression. Regular expression means that is finite automata. So it is working with finite automata. The lexical analysis, finite automata. Now, type checking normally done during when? Type checking normally done when? Yes, type checking normally done in syntax directed translation. Syntax directed translation following the cases that conversion of infix to postfix, calculation infix expression, creating acyclic graph, type checking, binary to decimal, 0-1 binary number, syntax tree, all the tasks of the syntax directed translation. These are the work going on here. Now tell me what will be the answer for this one. Yes, some code optimize carried out the intermediate code because enhance the portability compiler target process. That is the main target of the intermediate code generation. B is also correct, but this is more preferable. Now go for this one. One of the purpose of using intermediate code in the compiler. Why we are using the intermediate code in the compiler? Yes, to increase the reuse, because intermediate code is giving the reuse, machine independent code of the optimizer in the compiler, because you can reuse it. Okay, the semantic, after the semantic analysis, code is converted into intermediate code, so where hardware independent, it is totally independent to hardware and operating system. Now tell me what will be the answer for this one. All your algorithm is ultimately executing here. All your programming is ultimately executing here. That's why time complexity and space complexity is a big factor. I hope you can relate the subject now. Yes, the compiler, when you don't know, the size is not known during the compilation, then which you can use, that is the dynamic memory allocation. Dynamic memory, where what it is using the heap. Dynamic memory is using the heap. That heap is there. We learned the heap stack. So dynamic memory is using the heap here. That is related. Okay. Yes, now tell me what will be the answer for this one. Regular expression, push down automata, data flow, register allocation, syntax analysis, code generation, lexical analysis, code optimization. Till now we work lot with code optimization. So why this is required and which machine will help us to execute that? What are the machine we are using for what part? That is here. Yes, option 2 is the correct answer, because regular expression is related to lexical, because lexical analysis is doing token. Token means that is finite automata. Push down automata means grammar, parse tree. Syntax analysis is going on here. Data flow analysis is for that is here it is code optimization, and the register allocation is the code generation. At the time of generating code, you have to allocate the register. Without register you cannot generate, right? Now tell me what will be the answer. Lexical analysis, parsing, register allocation, expression evaluation, graph coloring, DFA minimization, post order traversal, production tree. What will be the answer? Yes, here your answer will be option 3. Lexical analysis is DFA. Parsing means what is going on in the parsing, that is production tree. Register allocation is graph coloring, because parsing means here the register allocation is the one version of graph coloring topic. And expression evaluation is the post order traversal, pre-order, post-order traversal. Okay, so this is the final one, last question. Here I am zooming it. You can see the optimizer, first row, second row, syntax analysis, parser, scanner. This is the last question. Which one is what? Tell me. This is the last question, and after that I will end the session. Your mind mapping is done. How to execute, what is the complexity, how to execute, what is there, what is graph, what is data structure, what is the utilization in AI. Everything is, I hope, clear. And after the class, please comment in the comment section. Those who are watching, those who are live, it is a request to everyone. You are commenting in the live chat, that will not show to everyone. Rather than that, if you after ending the class, if you come back in the class again, and little bit if you can put the effort to comment, that will help other learners. It will help YouTube the algorithm to send this video to suggest this video to other student. So little bit help you can do. Your engagement is more, you are commenting more, you like this video, you share this video, means YouTube can understand, okay, here is something, right? Because YouTube is not learning, they are checking that how the user experience is going on. So show your experience, then it will be good for me, good for Unify Study, good for all other students also. Tell me what will be the answer for this one. maybe it is little bit not visible. Here I am scrolling little bit one by one, and you can do the answer. Yes, answer is option A, because a part of compiler that is responsible to recognize the syntax, that is parser. So A will be with 3. A part of compiler that takes the input of the stream of the character and produce an output of the stream of word associated with syntactic categories, that is scanner. Scanning is going on in that way. The part of compiler that understands the meaning of the variable name and other symbol checks they used way for consistent their definition. Meaning means that is semantic. So C will be with 2. Instruction register to instruction register, IR to IR transfer, that tries to improve the IR program in some way, that is the part of optimization. Here that's why the optimization is required, optimizer. So that's why your answer will be this one. Okay, so I hope you like this video. Chalo, let's bye. Now let's see what we can do tomorrow as per your feedback in the comment section. As per your feedback in the comment section, not in the chat box. I will end the session. After that, come back here and please comment your feedback and your requirement. Put it into the comment section. As per your comment, I will try to arrange the class. Okay, hope for the best. Do your revision properly and 100% sure you will get the question. Bye. Thank you. Good night everyone. Good night. Good night. Bye bye.